Yeah, Roland.
Rowan. Okay. Numbers in a scientific context without units associated with them are not very valuable. And so being able to keep track of units and do math with numbers while accounting for the different units and getting your answer with the units that you want is a critical skill in all branches of science. And dimension analysis is a systematic way to keep track of your units and make sure that you're not making conversion errors and to get your ultimate results with the units that you want. So I'm going to walk through a couple of really simple examples. If you're familiar with this, then you probably don't need to watch, but if you're not comfortable with unit conversions and dimension analysis, then hopefully this will be useful. So a silly example that I like to use is if you're sitting at a market, outside of a market in Kenya, perhaps, and you're watching bicycles go by with chickens on the back of them headed to market, and maybe your question is, how many pounds of chicken per day are headed to market on the back of these bicycles? And so if I sit there and I make the observation that in the course of a day, 10 bikes go by, so 10 bikes per day, and on the back of each one of those bikes are 5 chickens, so 5 chickens.
Okay.
So 5 chickens per bike. And if each one of the chickens weighs 8 pounds, then we've got 8 pounds of chicken per chicken. Then we can use these numbers to get to how many pounds of chicken per day. So if we start with 10 bikes per every 1 day and 5 chickens for every 1 bike and 8 pounds for every pounds of chicken for every 1 chicken, then now we've got basically a series of fractions here, and we know that in a fraction, when you have the same number in the numerator and the denominator, you can cancel them out. We can think of units the same way, and so we can cancel bikes and bikes because it's in the numerator and the denominator, and we can cancel number of chickens and number of chickens here because it's in the numerator and denominator. And for units, then we're left with pounds of chicken per day. And so pounds of chicken per day are our units, and then we multiply the numbers across the top and divide by those on the bottom. In this case, we only have 1s on the bottom, so that's very simple. And then we multiply 10 by 5 by 8, which gives us 400. And so our result is 400 pounds of chicken per day. So this is kind of a silly example. I'll walk through another example with a more water quality oriented numbers. I'm going to shut it off and I'll grab another piece.